In this video, you will learn about the function and construction of water distribution systems. All building construction sites will include one or more water services. The construction manager then needs to have a basic understanding of their function and construction materials. One way to define a public water distribution system is that it is an underground system for the delivery, measurement, and sale of water for private use. In addition to private use, water distribution systems also provide water for fire protection. Let's take a look at how this water gets from the public water mains to the building. This is a K-8 school project, and we can see that there are 3 separate connections made to the same common water main, shown over here. And the 3 connections are in red, FS for fire service, so there's a connection there, WS in blue for water service, and in brown, IS for irrigation service. Notice that since the water main is located on the far side of the street, in order to make the connection, the street will have to be blocked off, excavated, and then restored once the connections are made. Also notice that there will be a meter outlined here, a meter and backflow preventer connected to each of the individual service lines. What are the sources of supply for the water distribution system? Public potable water, which is treated and tested to be safe for human consumption, usually comes from wells, reservoirs, rivers, or lakes. For irrigation, treated potable water may be used. However, some municipalities are starting to use treated wastewater. This is called gray or reuse water. This, of course, requires its own distribution system from the source. Sometimes private wells and ponds are also used to supply irrigation water. Let's learn a little bit about some of the design and construction considerations in a water distribution system. Municipal distribution systems are usually constructed under a publicly bid contract. In terms of a new residential subdivision, the land developer will often install all of the required utilities and then deed them over to the municipality for long-term operation and maintenance. In the case of commercial or industrial developments, the developer will install the utilities from the connection point at the property line and retain ownership of all of them on the site. Next thing to recognize is that water systems are under constant pressure, so pipelines don't have to be installed at any gradient like a sanitary or storm line would. 2 other considerations do come into play, though. First is that the water lines must be installed deep enough to prevent freezing during the winter months. This is a big deal in areas like Minnesota. And they must also be installed deep enough so that they will not be damaged by any vehicle traffic loads over the top of the pipe trench. The other issue is that water lines can be subject to some movement as consumption cycles on and off. This movement has the potential over time to cause leaks on the lines. To prevent this, the use of concrete blocking is required at all bends, fittings, and hydrants. Another consideration is the quality aspect of the water. Potable water, by definition, is drinking water quality. As water systems are constructed, 2 things are always required to ensure the integrity of the system. The first is a sustained pressure test, usually at about 200 psi, to make sure that no groundwater will leak into the line. And the other is that at the end of construction, lines are always flushed with clean water, chlorinated then to kill any bacteria, and then samples must be taken and submitted to a lab for bacteriological analysis before the line can be certified for potable water use. We saw earlier how connections were made for a school and an office building. Let's take a look at a residential development installation. This was a phased construction project near Charleston, South Carolina, and this gray line here represents the phase line. So this is a new construction above the gray line. The prior phase 8-inch water main, which is located right here, terminated with a temporary blow-off. At this point here, a valve and a temporary blow-off. The next phase of construction will remove this blow-off and connect going forward. Notice, too, that there is an existing hydrant. Hydrants are usually installed so that no house will be more than 500 feet away from a hydrant. There are more hydrants in the new phase, but they just don't show up on this segment of the plan. Okay, so the new 8-inch line is connected here and installed within the street right-of-way, but outside of the actual street pavement. Notice that whenever the pipe must change direction, such as here and here and here, that standard bends or fittings are used. And last, notice how individual water services are installed during the construction to each lot. In yellow here we have a long service, and it's called a long service because it goes across the street to a lot on the other side. And here we have a pair of short services, which are simply services located on the same side of the street as the water main. Okay, let's return to our earlier slide. In terms of future maintenance or repair work, you will find that many valves will be installed so that areas can be quickly isolated. And in terms of pipe location and prevention of accidental damage, many parts of the country require that a warning tape and wire be installed along a water line. And here's an example of that. This is a typical installation detail, and we can see here that a minimum of 4 foot of cover over the pipe is required. And about 2 feet below the surface, right here, a plastic warning tape must be installed as the trench is backfilled. And just above the pipe, right here, a copper wire must also be installed to assist in electronically locating the pipe in the future. There are 5 major components to a water distribution system. Let's take a quick look at them. The first is the water pipe itself, and we talked earlier about reuse of gray water for irrigation in some cities. It could be a real bad thing if gray water was mixed with potable water, so a very distinctive purple color is used for all reuse water systems. The choices for potable water mains in terms of materials are generally PVC, which is usually blue in color, or ductile iron pipe. For services, smaller diameter PVC or bendable copper is used. Our second component is fittings and bends. We saw an earlier example of this in the Charleston subdivision plans. And our third component is valves. Let's look at examples then of all 3 of these things we just discussed. On the upper left, we see some ductile iron pipe in a couple of different sizes. And to the right, we see blue PVC water pipe with a little bit of green sanitary pipe mixed in. Lower left is an example of a bend fitting, and to the right are a few gate valves. We talked about fire protection earlier. Exterior fire protection is provided by hydrants. In terms of construction, they are usually called hydrant assemblies. On the left, we see the plan of the assembly. And note here in green the thrust blocking behind the hydrant, and in blue the gate valve. And then between the hydrant and the gate valve, we see a short section of pipe here. And then on the right, we see an actual installation picture. And right behind the hydrant, we see the thrust blocking, and in this case, it's a couple of bags of saccrete. And then under the guy's coat here is a gate valve, and there's also a gate valve down at this end of the line here. And at the very bottom of the picture, we see the T-fitting where the hydrant line then branches off the main line. We have already mentioned the last component, taps and services. Let's take a look at this. On the lower left side, we see an illustration of how a tap is made to an existing line. A strap fitting called a tapping saddle is clamped over the pipe, and the threaded corporation stop shown here is installed. On the right side, we see a picture of a tap made with the tapping saddle on a Florida project.